In this video, I'm going to be covering a PowerPoint. So this is on gas tungsten arc welding of pipe. So this is part one of this PowerPoint for class Weld 208 Advanced Pipe Welding. So the objectives of this. After completing this chapter, the student should be able to describe how a pipe joint is prepared for welding, list the 4 most common root defects and the causes of each defect, discuss when and why a backing gas is used, explain the uses of a hot pass, and then sketch a single V-groove and indicate the locations and sequence of a weld for each position. Make a single V-groove butt welded joint on a pipe in any position, okay? Key terms that you will have to start getting familiar with. So backing gas, concavity, consumable inserts, gripes, incomplete fusion, root penetration, root reinforcement, and stress points. So, introduction. Gas tungsten arc welding pipe is used when the welded joint must have a high degree of integrity. A weld with integrity is one that is strong and free from defects that may cause the premature failure of the welded joint. GTAW welding gives industry the type of joints it needs. GTAW pipe welders are among the highest paid workers in the welding industry. Joint preparation. The ends of pipe must be grooved before welding. This pipe end preparation is to ensure a sound weld. The type of grooves used in preparing the ends of a pipe for welding will vary depending upon the pipe material, thickness, and application. Okay? So right here we have a V groove, making a V, a U groove, making a U, have a beveled angle, so we have a bevel, and then a regular piece of plate or pipe. We have a J groove, so it's making a J. V groove. The end of the pipe is prepared with a 37.5 degree bevel, leaving a root face of a 1/16 to an 1/8 inch. When both pipes are prepared in this manner, they form a 75 degree single V groove. The groove angle allows good visibility of the weld with a minimum amount of filler metal required to fill the groove. Okay? So here's your degree of 37.5. You would have another 37.5, and that would equal the 75 degrees. All right? V grooves continue. This joint cannot conduct enough heat away from the root pass to provide support for the molten root pass. Note the concave surface of the root face caused by the suck back. Alright? So right in here. The larger mass of metal helps to cool the puddle quickly and provides for sufficient surface tension, which also helps control the root surface. Joint cleaning. Before the joint is assembled, the welding surface must be clean and smooth so that they are uniform and free of contaminants. The band can be cleaned by grinding, brushing, or filing. The prepared edges must be clean and free from tears, cracks, slivers, or any other defects. Once the pipe surface has been cleaned, it is important that it not be touched with your hands because oil on your hands can contaminate the weld. Joint cleaning continued. The pipe is machine clean on the inside and outside surface. So just point to this picture. And then for this picture, the groove must be cleaned both outside and inside the pipe joint. Okay? Joint cleaning continued. Oily fingerprints, contamination, burn into the pipe surface by welding heat. So you'll see that right here. Joint cleaning continued. Location of tack welds on small diameter pipe. So we have it at the 12, 3, 6, and 9. Your tacks are going to be roughly 1 inch. Going over the root. The root of a weld is the deepest point into the joint where fusion between the base metal and filler metal occurs. The root penetration is the distance measured between the original surface of the joint and the deepest point of fusion. The root reinforcement is the amount of metal deposited on the back side of a welded joint. Root continued. The four most common root defects are incomplete fusion, concave root surface, which is sucked back, excessive root reinforcement, and root contamination. So, it's showing that in these pictures right here. Going over incomplete fusion. Sometimes a weld does not completely penetrate the joint, or there may be a lack of fusion on one or both sides of the root. The problem with incomplete fusion is that it can form a stress point. Stress points can result in the premature cracking or failure of the weld at a load well under its expected strength. Okay? So incomplete fusion, you see how the weld didn't tie in. Incomplete penetration, so it didn't actually penetrate through. Incomplete fusion continued. Incomplete fusion can be observed if the weld is subjected to a root bend test. A root bend test subjects a welded joint to a bending force so that the root of the weld is in tension. Okay? So whenever it's bent in half into like a horseshoe shape, you'll look along that, and if there's any tears, cracks, any porosity showing through, that will be a failed bend test. Incomplete fusion continued. One test that can be used is to simply secure the welded joint in a vise and use a hammer to bend the metal. Okay? So here's your joint, it would be straight, and then taking a hammer to where it's bent. This is the welded joint to see if it cracks, breaks. So, that is the end of this PowerPoint. There's going to be assignments, questions, discussion questions that you'll have to complete throughout this week. If you have any questions or concerns, please get in touch with me. Thanks.